start with doing some word problems involving quadratics. So typically speaking, when we have word problems involving quadratics, there's usually some form of projectile motion happening. So this is a perfect case of that. In this case, we have a function, and the function gives the height h in meters of a batted baseball as a function of the time t in seconds since the ball was hit. So we will be working with this given equation, and we have a bunch of questions to answer. Okay, so the first one is, what is the maximum height of the ball? So this is a key word, the word maximum, and we should be thinking right away that we're being asked about the vertex. And if we're being asked about the height of the ball, we're actually being asked for the h value. So if I look at the vertex of this guy, I know that the vertex is 2.5, 38.5. And because it's explained that h, its height as a function of the time seconds, we know that our x and y axes are as follows. Time is on the x-axis and height is the y-axis. So if it's asking me the max height of the ball, I know that the max height is 38.5 meters. And if it's asking me when it reaches maximum height, I know that the answer is the ball reaches this height at 2.5 seconds into flight. And it says, what was the height of the ball when it was hit? Now, this might not be intuitive to you, but if you think about it, you don't hit a baseball from the ground. You hit it from a bat, which presumably is in someone's hand, which is presumably not on the ground, but at probably between waist and shoulder height. So it's asking me when the ball, what the height of the ball was when it was hit. Now, this is another keyword, or another key sort of point in our parabola. When it was hit means when t equals 0. So the flight of this ball doesn't actually start until it was hit. So basically, what we're being asked for is the h-intercept. So what we do is we set t to 0 and we solve for h. All right, so we've done the first two questions and we know a little bit about the flight of our ball already. So I'm just going to draw a little sketch here. And I know my ball was hit and it goes in the air and it comes down. And I know that the vertex is at 2.5, 38.5. We're going to be asked in part E, we're going to be asked to figure this out more, or to draw this more nicely, so we'll wait until then to draw a nicer graph. So C, how many seconds after it was hit did the ball hit the ground to the nearest second? So hit the ground is another key point on our parabola. As you can imagine, that's when our height is 0. So let's give this a go. Okay, so I know h So now we're going to put into play what we learned in part 1 of this lesson. So we're going to want to use a lot of decimal places here so that we have the option to round later. Okay, so as you can see, there are actually two t-intercepts, and we're going to make sense of these when we graph it, but we have one more question to do before that. Okay, so part D is asking us, find the height of the ball 1 second after it was hit. So this is just asking us what happens what the height is when t equals 1, so we can just sub that in. Okay, so for part E, it says to sketch the graph labeling the h-intercept, the t-intercepts, and the vertex, and then it's asking us to state the domain and range. So let's plot everything we know about our parabola. So if you notice, this is a lot different than the 5-point mapping I asked you for in previous lessons. I'm not actually looking for the transformations of my 5 important points. Instead, I'm looking for intercepts. So let's plot them. We know that our y-intercept, which we found in part B, okay, our y-intercept, or our h-intercept, sorry, is 1. So we have 0, 1. We have two t-intercepts. We have one at negative 0.0331, comma 0. We have another one over here at 5 point. Okay, and we also know that the vertex is 2.5, comma 38.5. So it's not going to be dead in the middle, but it's going to be somewhere over here. So this is not to scale. Okay, now it's asking me something really important. It's asking me the domain and range of this function. Now I want to be really clear about this. This is a projectile, it's a ball. So even though I've used a parabola to model it, the parabola doesn't really know what it's modeling, but we know what it's modeling. And we know that the flight of the ball is only going to be the highlighted portion of this parabola, including this point and including this point. So actually, the domain and range of this parabola is not what it would be for your regular parabola. In this case, the domain is actually shorter. In this case, the domain starts at time equals 0, and it ends at time as 5.0331. The range of this parabola doesn't go all the way to negative infinity. The lowest point of our range is ground, so that means 0. And the highest point of our function is at 38.5. Okay, I believe we have one more question. When is the ball at a height of 20 meters? So what I'm going to do is set h to 20 and I'm going to solve. So if we go back to our graph, we can see that this makes sense. If I just look at the line height equals 20, okay, I can see that the 2 points where this is true is at 0.7441 in terms of time and 4.2559. All right, guys, I know it's a bit squished, but I think I got everything in there, and hopefully you can try the next one on your own. I will post the answer in our completed lesson document online.